Hi, good morning, scholars. Today we're going to be doing 4.5b, and our lesson objective is I will be able to represent problems using an input-output table. So the same thing we did yesterday, using numerical expressions to generate a pattern that follows a given number rule, representing the relationship of the values in the resulting sequence and their position in the sequence. So you will have 4 problems. Okay, in these 4 problems you will be finding the rules. All right, I'm going to start off with the I do. It says, the table shows the relationship between the position of a number in a pattern to its value. Which rule shows how to find the value when given the position? Okay, so again, I have a table and I'm looking for the rule. I have the position and I have the value, correct? So now it says, read and annotate the problem, complete the input and output on the process table. Okay, so let's go ahead and read and annotate again this problem. It says the table shows the relationship. Remember, relationship means the rule. So it shows the rule. I'm going to write here rule because I need to know that relationship, rule, and expression all mean the same thing. So the table shows the relationship or the rule between the position. Remember, position is the same thing as input. Position is the same thing as input. Between the position of a number in a pattern to its value. So we have the input and the number in a pattern to its value, that is my output. So basically they're saying, I have given you the input and the output. You need to find how to get from input to output, finding the rule. So scholars, they are asking me for the rule. And the rule, the process, the relationship, the expression, they all mean the same thing, okay? So remember that rule. I'm having trouble with my eraser today. With my pen. So remember that rule, process, relationship, and expression all mean the same thing. Okay, I'm going to just abbreviate here expression. It doesn't fit. Expression. Rule, expression, process, relationship, they all mean the same thing. So it says, which rule shows how to find the value when given the position? So I am looking for the value given my position, right? So I already know this is input. So I have made my annotations. This is what I know, right? Output. Excuse my handwriting. Okay, so I have my input and I have my output. I am looking for my rule. How do I go from here to here? From here to here. So there is a rule. Okay, and that rule is what I'm trying to find. All of these are rules. So I am looking for the rule that's going to help me go from input to output. So here, same thing. This is my position, P for position, and V for value. So I have my position again is 1, 2, 3, 4, and here it goes all the way to 4, but I'm going to just do one more, 5. All right, and then the output, I have 6, 12, 18, and 24. So I'm going to put it here, 6, 12, 18, 24. Ooh, what comes next? I don't know yet because I still need to find my process or my rule. right? I need to find my process or my rule. And I can either start by plugging in the rules that were already given to me, or I can start by doing my own, starting off with an addition or a multiplication or a division. What I do notice is that my output is getting larger, right? So if I'm just thinking about this right now, I know that I'm either adding or multiplying. I'm either adding or multiplying because I have whole numbers here. I have whole numbers. So if I have a whole number and I add it to something, another number, or I multiply by another number, that number is going to increase, right? So I can either do 1 times 1, nope. 1 times 2, no. 1 times 6. 1 times 6 gives me 6, but 2 times 6, okay, 2 times 6 gives me 12, okay, 3 times 6, that's 18, that's correct. 4 times 6 gives me 24, that's correct. So that's 5 times 6. That gives me what, 30. So that could possibly be my rule, right? That could possibly be my rule. Let me go check out the other one. So I'm going to put a little question mark here because I do have times 6. I didn't even realize that. The next one is times 3. Let's see. So 1 times 3 equals 6. No, that's not true. So I know it can't be 1 times 3. Nope. What about 1 plus 5? Yes, because 1 plus 5, that's an additive, right? That's an additive pattern that does equal 6, so that's correct. What about 2 plus 5? 2, because the pattern is plus, or the rule is plus 5. 2 plus 5 is 7. So I know that can't be my answer because my output or my value is 12, right? So I know that 2 plus 5 does not equal 12. It equals 7. So I know that can be my answer. Now, let's go ahead and say this one says plus 10. 1 plus 10. 1 plus 10 is 11. I have 6 as my output or as my value. So I know that can be it. So now that I have found this, I just need to verify by making sure that all of my inputs or all of my positions equal my value or my output. So 1 times 6 equals 6, yes. 2 times 6 equals 12, yes. 3 times 6 equals 18, yes. 4 times 6 equals 24, yes. So I know that my rule to go from position to value, the rule is times 6. Okay, so I found the pattern, right? So I read and annotated. I made my notes. I found my pattern. I applied the pattern to all my inputs, and that gave me my output. So that's how I knew which one was correct and which one was wrong. Now, if one pattern doesn't work, go on to the next one. Make sure you are doing your computation on the side, okay, so you do not get the wrong computation. All right, scholars, now it's your turn to do it. Now you're going to do the we do, the independent practice, and the DOL on the Google Forms. Okay, you're not going to do them on here. You will do them on your Google Forms. You guys got this.